right. Welcome back, everyone. I'm very, very excited about our next session. I've been mentioning Belmiro from CERN earlier. They have so much experience with upgrades. And, I personally just love the mission they're supporting at CERN. I was extremely privileged to be able to visit CERN last year, back when airplanes were still a thing. And the Large Hadron Collider, if you ever get a chance to visit, it's incredible. It's the largest machine that human beings have ever built. It's so big, it spans 2 countries underground, and they're trying to find that 95% of matter that's been missing. We don't know where it is. Mass, I don't know. I'm not a physicist, but I know a cool underground machine when I see one. So with that, I'm going to turn it over to Belmiro from CERN to moderate our next session, and we'll be using Etherpad and sharing that on the screen, and encourage everyone to get involved and listen to Belmiro as we go along here.
Hello, Mark. Hello, everyone. Can you hear me?
Sounds good.
Oh, great. Great. So it's great to be here today to talk about upgrades in a large-scale infrastructure. Let me share my video as well. Here we go. Can you see me?
Yep.
Yes, looks good.
Awesome. So my name is Belmiro Moreira. I'm a cloud engineer at CERN. CERN is the European Organization for Nuclear Research. I'm involved with the OpenStack community since the early beginning. So as Mark said, I will be moderating this session. Moderating a virtual session with hundreds of participants is also new to me. Of course, I need all your help on this. And this is a discussion roundtable. So please participate on this. So there are different ways that how you can participate. First one is the Etherpad. So we're gonna share the Etherpad in your screen. All right, it's right there. So please log into Etherpad. We have a few questions there. People start to populate with more questions. That is great. We're gonna follow up all the discussion on Etherpad, and it's great for reference. Second, you can interact with us also using the Zoom chat. If you have a question, you can use the chat. Also, you can use the raise your hand functionality, and then you will be able to participate in the discussion. So let's start this session. To help me to trigger the discussion, we have 2 active speakers, Mohammad and Eric McCormick. So I will ask them to introduce themselves and talk a little bit about their deployments. Mohammad, are you there?
Hi there. Thanks, Belmiro. Good morning, everyone. That's the cool thing, is it's not good morning today for everyone necessarily. My name is Mohammad. I've been involved in OpenStack for quite some time now. I think the last time I checked, probably almost like 9 years at this point. Been running OpenStack in production, both in public cloud and private cloud context. And, we have some clouds that have been running on for a really long time. I think like we have a cloud that's been upgraded since Diablo and it's still running today, which is, really interesting and fun. I also sit in the OpenStack technical committee as the chair at the moment. And also I'm a OpenStack Foundation board member.
Cool. Hey, this is Eric McCormick. Sorry for the loud.
Good morning, Pedro. Catching up from being out for a little while. Hopefully I can get through all my email this morning. Planning on.
Whoopsie. Can you all hear me? Hello?
Yes.
No, yes.
We can hear
Oh,
you.
okay.
Yes.
All right. Sorry, I got somebody else talking into my ear. Yeah, hi. So I'm Eric McCormick. I work for a small MSP called Cirrus 7. We run a couple of OpenStack regions, mainly focused on doing application architecture for startups, kind of providing those cloud resources that are hard to get when you don't have your own internal technical resources. We also run some of our own data analytics products, partially in OpenStack, partially on bare metal. And we've been doing OpenStack. I've personally been doing OpenStack. I hadn't really thought about it until the Foundation Twitter question came out. When was the first OpenStack event you attended? And my first one was Portland in April of 2013. So just before. So the first deployment I did was Grizzly, I think, and been active in the community ever since. I work with, I started out doing Puppet OpenStack and manual hacky deployments. Actually started with PackStack, like many people do. And then Puppet OpenStack modules and into Kola Ansible. And I've used those tools to deploy a number of other clouds too. I do some consulting on the side. So I maintain a few clouds that are not my own as well, and have been successfully upgrading them now for a period of time. And I also, some of you may have been to some of the forum sessions I've run on this very topic from back in the more Wild West days when upgrades weren't quite so great as they are now. So things have progressed a lot. So that's pretty much it for me.
Great, thank you, Eric. So I'm going to also talk a little bit about the CERN infrastructure. It went into production in 2013. Today, we have 2 regions, 72 Nova cells, more than 8K compute nodes, and more than 5K ironic managed nodes. We run more than 10 OpenStack projects, of course, the usual suspects, but also Barbican, Magnum, Raleigh, Mistral, and many others. And most of the cloud is running train in our case. I think that gives us a perspective how we should go through this discussion. We are here today to discuss upgrades because usually upgrades are seen by the operators as a hard thing to do. So that's why through the surveys, we are seeing a lot of deployments that are still running old releases. And this will be a way to understand why. So something that would be very cool today is to have a poll asking which versions of OpenStack are you running? And at the end, we can go through the results. So we'll launch the poll at the beginning. We managed to do that. And you're going to see the different options there about the different releases. Here we go. So please answer. And at the end, we will try to go through the results. Right. So something that we have been seeing in the surveys is that people are still running all deployments. It will be interesting to have your perspective. Why? So starting with Eric. Eric, you are running this discussion so many times in the ops meetups, also in summits. So why do you think people are still running these old and sometimes unmaintained versions?
Well, some of it is just the difficulty level of upgrading across versions. You know, starting, honestly, things didn't get to where it was, you know, I don't want to say easy, but, you know, a reasonable thing to upgrade every 6 months until fairly recently. So if you were on, you know, in my case, I was on Mitaka for a very long time. And the difficulty in it was just, you know, trying to get through one upgrade was really difficult. You know, being able to allocate the resources necessary to actually, you know, develop the orchestration necessary to do an upgrade and continue to run your cloud at the same time was difficult resource-wise. And once you fell behind, you were behind. And you have to go through every single version along the way. And that proved to be a major hindrance for people. So a lot of things got you know, improved along the way with things like Upgrade Checker, which will help you validate your configurations, and really primarily the work done by the orchestration tools. I think you know, Mohammed's team doing OpenStack Ansible, the Kola Ansible guys, Juju, OpenStack Helm. I imagine, I haven't played with it, but lots of them have spent, many of the deployment tools work together and really concentrated on that upgrade process. Triple O, they did a lot of work in it right up front with doing the fast forward upgrades, which was a topic we discussed in, I guess initially in Sydney at the summit. it was originally called skip level upgrades, and that was termed an evil term because we're not really skipping, you're just kind of passing through quickly. But that didn't used to be a practical option, and now in many deployment tools it has become that way. So I think anybody starting recently, probably since I don't know, maybe Queens, would be able to reasonably expect it to be okay to pass through more than one version. Still not the simplest thing. It still requires API downtime, but it's certainly a great deal better than it was a couple of years ago even. So thanks to everyone who put in all the effort developing the improvements on that.
Yeah, we will try to go through that later. Thank you, Eric. So sometimes in the OpenStack projects, we see these big jumps that you actually really need to upgrade a project. And it's a difficult upgrade. I'm thinking about Nova with introduction with placements or Cells v2, these moments where everyone needs to upgrade. Mohammad, so what do you think about these big jumps that everyone needs to follow? Would that be a reason that people are left behind?
Yeah, I think it's definitely a challenge. I mean, I very much remember our Cells v2 upgrade, and I think a lot of the larger operators definitely remember those. I think placement was a little easier, but I think it's kind of one of the challenges of, like, wanting to provide, the latest and greatest to our users, but also making sure that, we do it in a way where service availability isn't kind of impacted. I think also a big part of it is a lot of people maybe play I'm going to wait and see what everybody else feels about, like, how everybody else does the upgrade, and if they have other issues. It's like nobody wants to be the first one to upgrade. But then also at the same time, by doing that, there's kind of almost a stalemate where, like, nobody wants to be the first one. So nobody really ends up doing it, or very little do it. But yeah, I mean, some were definitely painful. I mean, like, just to kind of remember, I think our Cells v2 took like a really long time for the migration. And that's kind of part of why it's interesting when you're contributing, because we found out that there was like a bug where it would only do 50 VMs at a time as it was like migrating to Cells v2, which like really was impossible for it to finish at our scale. And so we had to kind of go and make changes to the code, like, while we're in the middle of an upgrade. So I think these are some of the experiences that might scare somebody the next time they want to do upgrade. They're like, oh my God, I don't know if I want to deal with this again, but I don't know.
Yeah, I completely agree with you. Thank you, Mohammad. I just would like to remind everyone that please participate in the discussion. If you want to join, just raise your hand and we will unmute your microphone. Of course, you can still follow on Etherpad. So moving on, because we see deployments moving much faster than others, this could also be to how they deploy their infrastructure. What are your comments on this? Because I see some deployments that have all the control in one node, one physical node, or three to be more resilient. And that can actually be an issue. Do you have some thoughts on that? Mohammad?
Yeah, I mean, so something that we've been doing a lot right now is actually moving a lot of running the control plane services inside Kubernetes. And what that has allowed us to do is it makes it a lot easier for us to prototype environments and see what the changes look like in a production environment very quickly. And also what it allows us to do is allows us to decompose the upgrades a lot easier. So we do upgrade like one service at a time, for example. And, when you're managing multiple clouds as well, it's really nice to be able to have the same exact like set of configurations, the same exact, read-only container that's running everywhere, versus something like when you're using an orchestration that, you know, might end up like, oh, you know, Bill changed this config at 3 in the morning 7 months ago when something went down, and now we just did an upgrade, and the state of the cloud is not what we expected it is to be. And so I feel like that's kind of one of the things that we've been doing. And OpenStack has been, because of how stable we are right now, it's been very easy to have mix and match of services. Like, so for example, in some clouds, you like Keystone, Magnum, and Heat running a Surrey, but the rest of the services are not there yet, and it runs just fine.
Yeah, you know, I think as far as even doing a, oh, sorry, hi, Derek again. Yeah, so I mean, running an HA control plane, I think has been, you know, one of the keys to having a successful upgrade strategy, because you can kind of pull one out and set it aside, you know, back up your databases and things like that, and then kind of tinker around with it. Having things containerized definitely made a big difference. I haven't yet tried to do things with Kubernetes. I'm just running straight Docker containers. But it does still, you know, allow in a you know, moderate sized deployment to, you know, kind of move control plane things around, leave stuff active while you kind of set stuff aside and mess with it, without necessarily having to have a completely separate deployment. So that's been, you know, a useful thing for, you know, kind of trial and error, and also in particular rollback. You know, I have done, before I had Kala doing more, you know, nuanced upgrade orchestration. You know, I would pull a controller and a database server off to the side and not upgrade them. Just leave everybody running on, you know, running on the other two while I upgraded that singleton, and then cut everything over through load balancers to the other upgraded control plane, to kind of minimize downtime a bit, and, you know, allow myself some wiggle room if things blew up, which they often did. I ran into some cells issues too, but not so much the migration thing. I just ended up with all of my instances somehow magically being in a cell that didn't previously exist, not cell 0 where they were supposed to end up. So that was before V2. It was kind of like in that transition phase, kind of strange. But I ran into some things like that. I ran into some weird things where database migrations would fail along the way. Had some Cinder issues where, you know, I had one little problem in with my Ceph configuration, because I run Ceph as a Cinder backend, and it would just kind of not do the database migration, but it didn't tell you why it couldn't do it. So it was having, you know, so I was able to troubleshoot those issues kind of off to the side. So life with only a small deployment and one controller is really hard. Definitely recommend people run more than one if they can, even if you have to run multiple containerized versions of the same thing on, you know, other hosts that are used for other things or combined services. It definitely helps to be able to shift things around as you're doing upgrades and maintenance and things like that.
Yeah, exactly. That is another point, where people run this. In a containerized environment on VMs, physical hardware, that can also help a lot during upgrades. I can give our example at CERN. So we run basically everything in VMs that are managed by OpenStack itself. And then separating all the components through different virtual machines help us a lot during upgrades, because then we just focused in the upgrade of one component and not the upgrade of the entire cloud. Is there anyone else operating in this way? I mean, with multiple VMs or in containers.
I feel like that's an interesting approach. I guess my question back to you is, how have you worried about, you know, potentially if there's an issue in the OpenStack cloud, which then makes your VMs inaccessible, and you kind of have that, like, you know, the cloud needs to run in order for the control plane to run. How have you dealt if you had any issues around that?
We never run into an issue like that. Usually if the control plane is completely down, our VMs still have network. So we use Bridge networking. And that is the main reason that we can run like this. We have some issues in the past because we also run some of the databases inside the OpenStack infrastructure. And we had some dependency issues when we needed to reboot the instance that was hosting the Neutron database. So you can imagine that was actually in the past a huge issue for us, because then the Neutron DB was down, which didn't allow to give that VM network at reboot time. But besides that, so now we moved that that instance to a physical node. So there is no similar issue. But mostly we don't have any issue with this architecture where we run the control plane inside the infrastructure itself. This inception, as we like to call it. Does that answer your question?
Yeah, no, I think that is a good answer, and yeah, it could be an interesting thing, but it's obviously very beneficial because you can reuse the same hardware. But also, I find it interesting. I think Clark put in the chat, if anybody sees continuous deployment from master as a valid option, and I'll start with hearing from you, Belmiro, because you're at a scale where continuous deployment might be a little hard, but maybe not.
Well, we never consider this option, running it from master. It's a little bit too risky for us. So we use the RDO distribution, and as soon the packages for an available release are there, so we start our upgrades. So currently we are running most of the components in train, and we start the upgrades to Zuri. I don't know, for our use case, it's not a very valid option. Because also lately with the latest developments, we don't get like that killer feature that we really need. We can actually just wait a little more months to get it. I don't know about you. I would like to hear others as well expressing their opinions.
I think the cadence of features has been reduced enough that it's running from master hasn't really been as beneficial, like to go through that effort in building the pipelines and everything else. I know when I first started out, that was the hotness. Everybody wanted to run from, you were running from master. Like Rackspace was like, oh, we run, from master. We build every day. We deploy every day. It's kind of it seemed like a great idea, but it's kind of terrifying and not necessary so much anymore as the bugs have reduced and the cadence of new required features instead of just nice to have or really cool features has come along. So I never had the time or resources to invest in building something like that, but whereas it used to be more desirable, I don't really find it to be quite so desirable anymore.
So have we reached a point where we can actually say that we can skip a version? What do you think?
It's not a skip so much as it depends on whether you're willing to have API downtime. That's still the trick. You still can't skip versions without an outage, which for some people is not practical. I can't. I don't know, Belmiro, you can tell me. I can't imagine that being an option for CERN, to take all of your APIs down to do an upgrade, but maybe it is. I don't know. I can probably get away with it, but it's not the easiest thing, I guess.
Well, is actually how we do it. We need to, during upgrade, we need to put down the APIs to do it. There are some services that this is not actually really required. So last time in Glance, we didn't shut down the APIs. And everything went fine. It was basically almost transparent to the users. But there are some projects like Nova that definitely we need to do it. I'd like to encourage others to participate. I'd like to hear your opinion. I see that there are other big deployments logged in this conference call. So please just unmute yourself, raise your hands, and join the discussion.
Yeah, sure. Prakash here, if you can hear me.
Yes, perfectly.
Yep. So I think we did delve into this in the interop. And as far as you are within the 3 releases, the scope is definitely there for a jump. That is, you can jump 1 or 2, but beyond that, there is no what you call guarantees at this time. And especially compute is the only one, NOAA is the only participating entity which ensures API interoperability, and that is at the level of what you call user APIs. But the administration API still may differ, and that's one of the catch-20s in the upgrades, I believe.
Right.
I noticed that Imtiaz left something in the chat about how they upgrade one component at a time as a strategy. Would you mind maybe talking a little bit more about that?
Sure. Can you guys hear me?
Yes.
Perfectly. Go ahead.
Yeah, so we are on Mitaka at OpenStack, like we're using Mitaka OpenStack at Workday. And what we found out is like our limitation for doing upgrades is like we have a short maintenance window during which we can do the upgrades. And if we try to upgrade all components, it poses a big challenge. Like not only it increases the risk of failure for any component that may go wrong, you're upgrading multiple database schemas and other things as well. So instead of doing that, what we started doing is to containerize all components first and then upgrade one component at a time. And when we try individually, it seems like one of the components go much faster. And not only that, like you can have your own schedule and we can upgrade one component, let's say within a given like 1 hour downtime. So that seems like a very like practical strategy for us, but let's a lot of the off-the-shelf solution or if vendor provided solutions don't quite support that option. So we had to develop our own tools to make that possible.
Yeah, I actually used to do, Sarek, I used to do the same thing when I was using Puppet for everything, and I was building my own orchestration layer and stuff. I actually used to do exactly that. I'd upgrade Keystone, and then I'd do Lance and Cinder, and then Nova last usually. But yeah, that definitely made things feel safer, and I could address a problem with a single service at a single time. Since I've been using other people's orchestration and just tweaking it to my own liking, I haven't done it as much, but that's definitely a really good strategy.
Yeah.
I'm curious, Imtiaz. Hey.
Oh, go ahead, Belmiro.
Go on. I was curious about what Imtiaz said about the containerization. I'm curious about the orchestration that you use for all of this.
We are planning to use Ansible for containerization. We have a little bit of like compatibility issues. Like our current infrastructure is mostly Chef managed. So we had to go with sort of a hodgepodge solution where the configuration is laid down by Chef, but the orchestration is done with Ansible. We're trying to move away with it. We were looking at Cola Ansible, but somehow we found like the architecture that the Cola Ansible expects is very prescriptive. We like used a slightly different deployment architecture, but we couldn't quite use it as is. So that's where we are at. Like I think I would like to think of it this as an intermediate phase before we can all switch to like fully to one solution and not have a like mixed one.
Sorry, just to chime in here. So Blizzard here. We went a very, very similar route as you guys. We containerized, we made our own containers, we did our own orchestration system using, well, we used Puppet and Ansible. Templatized all our configurations, and we upgraded them one by one as well, starting with we started with Keystone, then we did Nova, we did Glance, and then Swift, and then we did Nova and Neutron at the same time. And we didn't do containers though on the computes just because we found that too complicated. And we wanted to go Cola as well, but we had already made so many decisions in our history that it was very difficult to adapt, like the Kola deployment basically, but very similar otherwise, and worked great for us.
So now that we have Kubernetes and OpenStack Elm, is anyone considering that?
I mean,
well, we are considering that. That's why I'm asking about your experience as well.
We went the path of building a Kubernetes operator for OpenStack. So it pretty much is using Kubernetes, but rather than having kind of just Helm charts or yeah, pretty much just Helm charts or anything like that, we went the path of an operator because we wanted the ability of actually using some logic, right? Because we know in these upgrades, there's a lot of logic. There's this has to go before that and whatnot. And that's hard to codify inside of a bunch of Kubernetes manifests. But in an operator, we're able to actually do something where we actually can embed logic into it so it can do the right thing at the right time, whether like if it's a cells v2 or whatever migration, then it would do the appropriate migration using containers inside Kubernetes. But also, I'm also curious, I noticed Javier left a comment that they can't upgrade every year as stability is important. And I wonder, I want to ask a little bit more if it's like the API level stability, or is it the worry that the data plane might go down, or is it the, just kind of curious what stability is in that context. If you can feel free to unmute and speak up if you want, Kabir. If not, then
okay. When you're ready, just please. Oh, okay.
Somebody a few minutes ago talked about it's safe. I'll read it out. Upgrading single services at a time makes things feel safer. Was there a and then we moved on to?
Oh, I guess that was me, Eric. Yeah, as far as like what I'm doing now, yeah, I mean I'm doing them all kind of as sequentially with you know, with call Ansible, just running the entire upgrade at once usually. When I was doing my own orchestration with Puppet, I generally did it one at a time because for safety and in case I blew something up, because the orchestration was all on me at that point, and I mean literally just me. So bugs happen, and my testing environment was small and not, you know, really adequate to test everything that I needed to upgrade. So it was definitely safer to segment and do it over multiple days and, you know, sleep in between and things like that. You know, now it's not quite as scary. I have more testing resources, multiple regions, so I can do, you know, I can do a smaller region to begin with, and, you know, try things out better. So it's less terrifying, and so I don't worry about it anymore. But I can definitely see it being a good, you know, a good strategy for especially larger deployments where it might take a really long time to execute an upgrade. Like, you know, especially those using Ansible, it's not, you know, it's not known for its lightning speed, in particular when upgrading like a crap load of nodes. So, you know, so I can definitely see segmenting it as a possible advantage still.
Thanks, Eric.
Thank you.
We're in the midst of using Puppet OpenStack in a very similar way to you're describing, and I'm hoping that means we can follow your path further along.
Yeah, sure. It's definitely still doable, and those modules are great, and have been, you know, have been for a long time. I just had some other requirements, but yeah, it should be totally doable.
Yeah. So as I say, we're using Puppet OpenStack in that way, but following along to using something like Cola Ansible looks pretty attractive.
Thank you.
Anyway, thanks.
So I also suggest that now we move a little bit through the questions that we have on the chat. So Asa Alashari made a question about algorithms to calculate the number of nodes. I don't really fully understand the question. Can you clarify a little bit, Hassan? If you want to unmute. Okay, when you're ready, just raise your hand, please, if you would like to discuss this further.
Hello, sir.
Hey.
There he is.
Yeah,
Okay.
I'm Hassan. I was asked a question about how can I know the number of nodes to deploy in my infrastructure depending on the physical server.
So
I think I can
talking
try
about
to help.
Can I, or any algorithm or something to calculate how number of a node I need to dependent on my physical server? Like if I have 10 server, how can I distribute the compute like controller? How can I number of controller and number of other service? How can I distribute them between the server?
I think this maybe ties up a little bit to what some of the Blizzard folks were talking today. I asked this earlier about how they split their infrastructure on like how they have, you know, X amount of RabbitMQ machines and whatnot. But, you know, this is like one of those very, very interesting problems that I think if anyone had that magical answer for, you would make a lot of money, but no one has that magical answer for it. But most of the time, I would say most OpenStack deployments, if you want to have HA and you're something like at a 10 servers, you're probably looking at 3 controllers that are running all of the OpenStack control plane services. And then the rest could be your compute nodes. That just could be an example. And to be honest, that probably can scale up to a pretty reasonable number where you just have 3 control plane nodes. The cases that we're talking about when users like Blizzard and CERN start to scale out their RabbitMQ and whatever, you know, you're going to be you're going to know when it's time to do that, and you're going to be kind of in a different position as kind of versus starting. So I would say there isn't really an exact number to answer that, but you know, generally the 3 controllers I'd say is the most popular choice until, you know, there's not really an answer. You just have to understand your environment and the way that it's built.
That is something that the large-scale SIG is trying to answer. So cell, how can we scale a cell? What are the numbers? So actually we are asking for people to give their feedback and their user stories into the SIG, because that is very interesting numbers for everyone. And of course, because everyone deploys OpenStack in a different way, the numbers will be different. But at the end, we're going to get very important information and different considerations how to deploy the infrastructure. Thank you for your question.
May I ask another question?
Yes,
rudely. What is considered a large installation, and where do we start to see the scaling issues? If this is a large installation, big, like just about the scale we are discussing.
It's very hard to answer that because I think everyone has a different answer of what is large. Depending on your use case, 100 compute nodes could be extremely large. For others, 1,000 or 12,000, as Lisa mentioned, are okay. But of course, sometimes when you scale, also you need to give up something. So don't expect in a very large infrastructure to have all the functionality that you probably have in a 10-node infrastructure.
Yeah, I think a big driver in this as well is how busy the cloud is. So for example, you know, we have clouds that are really large in terms of compute nodes, but they sit very idle and they don't do much. The VMs just run, so the OpenStack control plane isn't busy. On the other side, we have clouds that are smaller in scale, but for example, see anything from 100 to 200 VMs getting spawned every hour. And so the work that happens in creating all these ports and creating all these VMs nonstop could have a huge impact on your control plane versus one environment that's sitting idle with a lot of VMs. So that pattern has to be also taken into consideration, which is like, how are you using the infrastructure?
Thank you. That is actually an excellent answer. And what I'm now wondering, do we have any indication on which factors contribute to the so-called, I'm air quoting, but it's hard to see, large scale, and how much they affect just for infrastructure planning purposes?
Like for X compute nodes, you need Y size control plane.
Pretty much, or for like 500 requests a minute, you need, it'll affect your control plane this much.
This is very hard to say.
Because there's so many different ways to connect all the building blocks at OpenStack. It's very difficult to produce a single document like that. And there's so many different approaches to even how people build their control planes. Like I think so CERN uses like the inception method of using VMs. We use all bare metal for our control plane. You know, currently we dedicate one function per bare metal node. So it's extremely difficult to extrapolate something from that.
I think that is perfectly the answer I was looking for. So the answer is there are no magical numbers lying around somewhere that I just haven't found.
Yeah.
Yeah, correct.
Engineer everything.
So as I said, we are trying to collect different experiences in the large scale SIG for people that have an idea, considering this deployment, the scale that they can reach. Thank you, Kyle. So continuing the questions that we have in the chat, there is one very interesting. Dishkshan Shavan is asking about the strategy for live migration when facing hardware issues. I relate this with upgrades as well, because we are only talking about OpenStack upgrades, but we also need to provide and do the OS upgrades, the operating system upgrades. And now moving from Python 2.7 to Python 3, and everyone upgrading their distribution, that probably is a big issue. So one of the models that people may thinking how to upgrade OpenStack to move forward now that Python 3 is required is actually live migrate instances to new compute nodes. But that means live migrate instances to new versions of QEMU, new kernel, many other things. So what are your thoughts on this? This is something that we have been thinking about, but having live migration between different QEMU versions, it's extremely hard that this model works. Do you have any comment on this?
So from an upgrades perspective, it's really a huge challenge in terms of like making sure that all of your different QEMU versions are all at the same time. I know that we're talking about kind of large scale upgrades in this case, and I think one of the challenges is if you deploy, you start with, let's say, an arbitrary number, a fleet of 1,000 machines, and then you add another 1,000, a year or two down the line. Generally, the kernel versions are maybe not going to be matching. A lot of things are not going to be matching from the first 1,000 batch to the other 1,000. And so a lot of times that's where you start getting to some really interesting issues with live migrations, not being supported back and forth. And I think that's where it can get really hard. Also, a lot of times I think the problem with live migrations is when you're trying to do upgrades, is there's a huge challenge in the testability of live migrations. And you can be in a situation where something happened 6 months ago, and that just locked an entire compute node or a set of compute nodes to not be live migratable. We just recently ran into this. We started having machines with host model instead, so we exposed the direct host model to the VM. But turns out the version of QEMU that we run blocks live migrations if the VMX flag or an SM virtualization is exposed, which means we have a huge fleet of servers that are literally not live migratable with like, and you couldn't plan for these things. They just appear and then they become a challenge in your upgrade process. And so those are the things that are, you know, very, very hard to resolve and figure out. And I maybe want to hear about other you know, operators that are here about, you know, this a strategy of keeping all your fleet consistent, even as you add more systems to your fleet to make sure that upgrades are happening easier.
From my perspective, I always have run with a custom CPU type, and I haven't used host pass-through for quite some time. I had some particular problems with, I don't know if it was just an Ubuntu, particular Ubuntu version, but I think it started with 16.04, where I couldn't even boot an Ubuntu instance on you know, the latest Intel processor because of some particular feature that it didn't like. I can't even remember which one. And then I got smaller batches of hardware as well, so I ended up, like you said, with, you know, a fleet of, you know, special snowflakes that couldn't take VMs from the other things. So quite a while ago, I switched to just a custom CPU type with a kind of base level of features allocated to them, and you know, and ignoring what was actually in the box. I didn't have anybody that had a particular need for some bleeding edge CPU feature, but I suppose if I ran into that, I'd just make some sort of host aggregate of machines that, you know, could support that in kind of a smaller subset with a, you know, special flavor and whatever that would give them that CPU feature. But thus far, I haven't had that need. So.
Yeah, it's a very, very hard issue. We are suffering from this as well. And what I see now moving to Suri, that we need to also upgrade our distribution. That will be even a very disruptive upgrade, because probably we'll not be able to migrate to a different OS version, our current instances.
I also know that it's very early on the West Coast, but I would love to hear more from James Pennick about how they maintain their fleet to be as consistent as they can, because they also operate at a larger scale.
Although, J-Roll, are you on? I might pitch it. Jim, I see you're on if you wanted to chime in here.
I'm here.
I wonder if you want to talk about what we're doing with Chef and what we're doing currently, and then if you also want to, you can also touch on what your next version of the architecture is.
Right. So currently we have just kind of a basic Chef deployment. We pin versions of our cookbooks, and we pin RPMs. Then we have our CI/CD system take care of bumping those pins as necessary and putting it through the testing phases. We're working on moving to containers. We've got the first container hitting production this week. And then we are also moving to like a Chef solo model. We're, you know, taking out the Chef server and just running Chef solo from each machine. And eventually we'd like to get into a model where we can reboot or rebuild a machine and have it automatically deploy itself at startup. And, you know, that way you erase any manual configuration you've had, you erase any, just any state on that machine, right? And basically like giving it a fresh machine. Something we already do today is OS upgrades every 90 days. So that gives us a good opportunity for a fresh start right now, but we'd like to be doing that more frequently.
Thank you, sir.
Sure.
Thank you. So I suggest now that we focus on the Etherpad. We have A lot of information there. How about we move to how to validate the upgrades? I think we touched the other topics a little bit. So are you guys validating your upgrades? We have some examples here. Gregorio, you'd like to talk a little bit about it? You add some lines in the header pad.
Yeah, sure. So we run I chuck together a Terraform script that creates some instances and storage volumes and network things on a regular basis, and then we have that running all the time, and then we run it during and after upgrades to check that everything's still working properly. That's all we're up to so far. We want to deploy Rally, but we haven't got there yet.
Right. Someone else that want to talk about their infrastructure to validate upgrades? You're starting to have a lot of examples here. Don't be shy.
Just to speak on what we do, we have a Rally Prometheus exporter that runs Rally every 5 minutes and exports all that data out, which is scraped by our Prometheus. And so one of the things that we do is pretty much have Rally running against the cloud every 5 minutes with a bunch of SLA requirements that are codified inside Rally. And then we just make sure those are all always running and passing. And that's kind of a continuous signal of, have we broken anything or not yet? That can alert us every 5 minutes or so. So that's something that we do.
But you have like an independent infrastructure where you upgrade, you run your Rally tests, and that validates your upgrade. That's it?
Well, no, so the Rally runs all the time. It's like almost a monitoring signal of the cloud. And the other kind of interesting thing is the upgrade is validated inside. The way that we're going towards is the upgrade is validated inside our CI. So Zool is actually building all the images, deploying the cloud entirely, running Tempest against it, and pretty much validating it as much as possible. And then after that, so by the time we're pretty confident when we go to the production that everything works, because it's tested with the same exact config in a virtual machine environment. And so Rally, I'm getting some questions about the Rally. So it's actually published right here on OpenDev, if anyone wants to use it. It's a little hacky. It reads like the SQL database, and there's some locking and whatever, but it'll run a task every 5 minutes, and I can share the thing that we run in a paste bin later.
That's something I've been looking for.
In large info. Sorry, Eric.
No, go ahead.
I was saying that I think Rally is very popular in large infrastructures. We actually also run Rally. Every hour, basically, we have a very large set of tests that we run in our cloud to validate that everything is running fine. And for us, for the upgrades, we basically have a side cloud infrastructure, completely independent, where we upgrade the component that we are interested, and then we run all the Rally tests that we have, and plus other validation tests that operators do. That is the main feedback that we get for the upgrade, if it's okay or not. Eric, sorry.
I was just going to say, yeah, if anybody has any jobs that are generic enough to contribute, to put an upstream repo for other people to use as kind of a model for how to build these things, then by all means, if you don't know where to put them, we can always put them in one of the OSOps repos, or feel free to contact me. I'm happy to help you share those things if you would like to.
Great, thank you. So at the beginning of this discussion, I asked you to fill up the poll for the versions. I think we're gonna end that soon. So if you didn't answer yet, please do it. Thank you. How about we move to, say again?
Address one of the database questions. on how everybody validates their database upgrades, and I'm wondering if what we do is a common process. We actually take, before our big upgrades, we take our dump of our production database and we run it through our devel system through all the upgrade hoops to see if it works. Because earlier we have had issues that we have had some UTF or other problems with our database, and on the upgrade day, our upgrade was slow because we had to firefight issues. And after that, we have always done a production database upgrade run before this. And this has proved super useful. We almost always find problems that we have to fix before the upgrade day.
Yeah, that is great. That moves us to the next question that we have on the Etherpad about the rest of the infrastructure, RabbitMQ, MySQL. Anyone with a war story about Rabbit?
I think going to the database question, yeah, I've seen these issues many times in the past, and that's usually when it's like an older database that's being upgraded. And a lot of times, yeah, it's UTF-8 and things like that. I don't think we've ever, personally at our site, done like a database dump in a simulated DB sync somewhere else. It's just mostly been fix it at the time that it shows up. But I think that's a really interesting thing that you bring up. And RabbitMQ, I mean, we have something that we call the magical playbook that we don't know how it fixes Rabbit, but it pretty much like re-bootstraps the cluster by reinstalling it. And somehow it works after. This has been an issue with like the 3.7 series. Moving to 3.8, we don't have that magical playbook needed anymore. But I mean, it's literally just called the magical playbook. We don't even know what we're doing at this point. We've tried to manually figure out what the deal is. But pretty much what happens is the OpenStack services refuse to consume the queues inside Rabbit. And even though Rabbit's holding that queue, the messages just keep accumulating. And no amount of restarting OpenStack services resolves it. The whole cluster, the whole RabbitMQ cluster being restarted ends up resolving it. And we haven't been able to detect any signal of figuring out why or how. But that's kind of for us with Rabbit. But 3.8 has been good to us.
Okay, so you have the magic playbook. Nice.
Yeah, the magic playbook is nothing but the OpenStack Ansible's like deploy playbook with a bootstrap flag on, and that's it.
So I think I can say that then we have the unicorn deployment decision at CERN. So basically we avoid to run RabbitMQ clusters unless it's extremely necessary. So in most of the cases, we only run with one RabbitMQ for the services. And that solves basically all the headaches of managing a cluster, even upgrades.
Are you running multiple Rabbits per, I mean, I know you guys probably, for each cell and things, but per service, like you run one for Nova, one for Cinder, or is it all just?
Yeah, that is an interesting point. So we have separate Rabbits for each component. Of course, we have Rabbit clusters for Neutron, for example, because all the loads. But for Nova per cell, we only have one RabbitMQ per cell, and that is an independent VM. And nothing of this is shared with other services. So Cinder has their own Rabbit infrastructure, Ironic as well.
We had actually talked about that in a session Mohammad ran over in Shanghai about doing that as a kind of a solution for some of the Rabbit headaches. So it's good to know somebody like, well, Huge is already doing that in production. So it's good validation.
Of course, we don't have a cluster, so we don't have high availability on that. But also we don't have the issues of the cluster at the end.
I think our goal, our goal here is we're trying to, as we're moving to the operator and running things in Kubernetes, we're kind of actually trying to move towards running a single like stateless RabbitMQ. especially for things that are not going to involve notifications or anything like that. And we just kind of rely on Kubernetes making sure that that pod is always going back up somewhere else. So, you know, that's kind of our mechanism to rely and make sure that that RabbitMQ is running somewhere. So yeah, we're also thinking of, or not thinking, we're trying to move to that architecture. It's just right now we're in the middle of migrating things to Kubernetes, and our legacy existing Rabbit is still running.
You mentioned migrating to Kubernetes several times already, Mohammad. That is very interesting. We are actually interested as well. But there are still some limitations in OpenStack components migrating to Kubernetes because this application was not developed to run on top of container orchestration. I can give you an example. For example, Nova will try to create a service when it's running in one machine, meaning that if it's running in a container, every time something is replaced, we'll create a new service and a new service. Has there been any conversation with developers about this? Do you know?
I think I haven't reached out at that point, but I think some of the workarounds we're thinking about for something like this is enforcing something like a daemon set that runs so that it runs on specific hosts that are going to be your control plane hosts. And so as we add more nodes that are tagged as control plane, that's where they run, and running it with something like host network on so that it actually gets the node host name injected. Another thing that we've actually been thinking about is using the node name, using the Kubernetes like API where you can expose it as an environment variable. And you can configure Nova using environment variable if you want to keep it running inside the, without exposing it to the host network. But, you know, I agree. There's challenges to be there, but I think there's a lot of value in moving towards there.
Yeah, I completely agree. So let's continue to move on in our Etherpad list of questions and topics. One question that we have is, what is the easiest and the more complex project to upgrade? You have a consensus here?
My vote is Keystone.
Complex or easiest?
Oh, easiest. Keystone's definitely the easiest because it's just an API with a database. It's just a simple RESTful API. It's scary because it's like the thing that everything depends on, but it's generally pretty easy.
I definitely agree on that front. Hardest one, I would probably say Neutron. I've somehow blown up Horizon multiple times, so I really don't think it should have been that hard. But I've managed to nuke it more than once. But yeah, besides that, probably Neutron, even more so than Nova. And if you're running any kind of funky plugins or something goes haywire in a bridge config that takes stuff out, there's just a lot of moving parts Neutron-wise that can cause problems. Not anything wrong with Neutron in particular. There's just a lot of things going on in there.
Yeah, completely agree. All right, so please give your opinion. That is pretty interesting. If I need to vote, I'll vote in Nova for the more complex, but probably that is related to the size of the infrastructure that we have.
I think ironic layered in there probably adds complication for your site as well, I'd imagine, doesn't it?
It's more related with Nova, the complication, because ironic, you have the API, and then you have all the interaction with the Nova API, with the Nova compute node. And scaling that, it's a little bit tricky, and we have been learning a lot and actually sharing our experience regarding conductor groups and what we are doing. All right, so what are the changes that you would like to see in the future? So a lot have been improving. So the first upgrades that I did a lot of years ago, they are completely different now. What are the main challenges that's still remaining? So the developers are doing a great work easing all this path, but what do you think that can still be improved? Any take on that?
Yeah, I mean, from my perspective, I would still someday like to see a true skip level upgrade. I don't ask for it anymore, but I think it's been, I would love for it to happen one day if we had the bandwidth and developer resources to actually make it happen. Zero downtime, multi-version upgrade would be great, because we still have a lot of people who it's too much to bite off. Upgrading even once a year sometimes. And it would be nice for them to be able to catch up without having to hop through, long outages and things like that. So long term, I would really like to see that. And potentially, we've talked before about, slowing down the release cadence at some point, now that the requirement for, critical features is not quite so great. So I think that sometime that might be a discussion worth having. Could also help people not get so far behind and really plan around a longer release schedule.
Yeah, I completely agree with that. I think that having upgrade without API disruption is already possible in a few projects. If they don't change the DB schema, that is basically possible. We did that with Glance in the past several times. However, with projects that also involve messaging, that is much more complicated, like Nova. Any other comments on this?
How about better rolling upgrades?
Right.
Yeah.
Go ahead, Eric.
No, I agree. Rolling upgrades would be another way to do that, right? Some projects are kind of more geared towards that than I know Nova, and for example, a lot of the lazy database migrations and things like that going on. There's work in that area. It's still not a multi-version thing. It's still end-to-end plus one. So I would, sometime like it to see it be a, more than one version, at least N plus two update.
It's also important in the edge, rolling upgrades in the edge, because you can't upgrade everything all at once.
Yeah.
Right.
I want to make I noticed John had their hand up. I'd be curious to hear what they have to say.
Oh, hey, yeah, I raised my hand because I was going to ask a question about if anyone's actually tried leaving the Nova API on during the upgrade, and actually tried the role, because the Nova upgrade was also very much designed for allowing to have older computes running for a while. So the idea is the API you could get done first and then leave your computes, if you've got lots of computes to do, behind. I'm curious what people's experience of that is.
You're talking just for a single version upgrade. I leave it on all the time. I don't ever turn it off for a single version upgrade.
Well, I guess I'm using Color Ansible too, so I'm using the same same
well,
logic to do exactly that, right?
Yeah.
So I concur, but perhaps because I'm using the same code.
Yeah, I mean, I did it with Puppet too, even back, from the time they first put in the what was it? I can't remember what the config flag is called.
Schema migration.
Yeah. Yeah, so you could tell the computes that they were tell the API that it had old computes. Yeah, so you could tell the thing you were to allow old Nova computes and then just leave it running. So ever since that came in, like Juno or something, I've been using that.
Cool. I was just wondering if anyone else.
I'm not using that. I think it's still too risky. When you have a lot of components with a lot of cells behind, it's a lot of control plane.
Yeah, I mean, in terms of the N to N plus 2, I think it's also risky in terms of the testing matrix, right? So there is risk there for sure.
Yeah.
Depends which route you test through the journey. Don't know if anyone else has experience on that.
we've generally tried to turn things off. But another open question I'd like to ask for everyone is, has anyone used the upgrade? I forgot what we call them now. Upgrade checkers. Has anyone taken advantage of upgrade checkers as they upgraded their cloud? So that's the like Nova Manage, I think upgrade check, and then all the other services also added a couple of upgrade checkers.
Well, I think it's very nice that we have that in the code. It's something that we used it last time, but it was something that we are already doing. So it was in our tools, so it was nothing new for us. Because the upgrade checkers basically checks if you are running the latest version of your database schema. Any other take on that? Okay. I think we move on then. Mohammad, was that okay?
Yeah, I mean, it's. I guess maybe people can leave it a little bit later in the in the Etherpad or in the chat at any time.
Okay, so I'm gonna end the poll now. I expect that most of you already voted. Actually, yes. So here you go. Can you see the results?
Yeah.
So this is actually pretty cool. So most of the people are running Train. Already 7%.
Yeah, but significant other things, and I didn't get to vote for some reason, and I'm on Newton. So with
you are represented as well, even if you didn't vote it.
Okay.
Newton is still in the list. Can you all see the results?
Yeah,
Yeah,
they popped up on my screen.
It's actually pretty great. We had the discussion in at the Ops meetup in London about how this sort of poll has shifted. We've if you go back and like pull up the Ops meetup wiki and look at previous Ops meetups, there's always this poll, and I would say since since Queens and later, this thing has definitely shifted towards the newer side.
Well, that's good.
There's still an ice house or an ice house and a kilo floating around out there, I think, from the last one. But there used to be 0 on the latest version and maybe like 1 or 2 on the N-1, and then it would start to balloon out as you got back towards Mitaka. There was a big block there between Mitaka and Newton for a long time.
Yeah. Well, we went from kilo to Newton, but I don't know. I think I know there's rumors that we're moving to Queens or Rocky. So.
All right.
It's certainly way better than the earliest user surveys were. I remember those, and there was a lot of caution about upgrading.
Yes. What was
terrifying.
Yeah, what was that company that was stuck on Cactus? Was one of the eBay subsidiaries. It was stuck on Cactus for years.
God. I know there was definitely a couple of Essex ones floating around out there, even up until a couple of years ago too. I can't remember who it was now, but I'm sure I could go back and find that and stick it on the Etherpad just from one of the old Ops meetups.
Right. But actually what this means is upgrades are actually working and people are actually upgrading. So I suspect that upgrades are actually getting easy for people to do this operation.
Yeah.
So
we've our newer clusters we found been much easier to upgrade than our older ones. So we used to get stuck way back in versions, and a lot of getting stuck back in time was actually due to all the patches that we put in. So the more we patched things in, the more we were kind of stuck, and the larger effort it was to move forward. But it seems like it's gotten a lot easier with, especially there's stuff that's running Rocky and above.
Right.
Well, but we also have a number of different versions in the company, right? So we have at least 3 or 4 that I know of.
Yeah, for sure. But even those newer clusters James mentioned are a variety of versions, just due to, we upgrade single components as well. So we have some stuff on Train and some on Rocky in there.
Right.
All right. So we are trying to wrap up the session. We have 15 minutes. And actually, Panic touched a very good point about custom patches that everyone has. And they are actually a pain when we are trying to upgrade, because we need to then migrate that to a new version, test that ourselves. So I'm curious, what's your take on that? Are you still running custom patches in your clouds?
Oh yeah, yeah. We still have a lot. Our newest clouds have far fewer patches, but for most of our stuff, just because we are running such large clusters it's really not about the size of the cluster. It's about the type of use cases we're trying to handle. So some of it is, tying in with internal asset management systems. Instead of someone boots an instance, we needed to go into an asset management database just so we're aware of who is using that asset at that point in time. And while our goal is to, over time, change the way we've been interacting with these things, we still do have quite a few patches. But every upgrade, what we're trying to do is, as we work with the community to share some of our experiences and get things into OpenStack, we're also then trying to, as we upgrade, start pulling all of our custom patches out and changing the way that we have patched things into OpenStack into being more maintainable, more driver-based or plugin-based, whatever possible, or even ultimately for some things, Jim's had a design for moving some things to actually just react to messages coming across the queue. So that's sort of the end game for us, and the sooner we get there, the better. But I will say, I guess, just sort of as almost like a soundbite, that I've only ever regretted not getting something upstream, but I've never regretted the inverse, right? I've never regretted working with the community to get something upstream, because it always makes things a lot easier for us.
Any other take on this? So in the past, we had the discussion to have plugins in an easy way into OpenStack to be easy for people to add their own patches. I think that died a little bit. Well, we have plugins like in Neutron, but for example, in Nova, actually when it's a custom patch, it's a custom disruptive patch. Could that be a way that the community could follow to solve this? Everyone have some kind of custom patch?
Can I chime in there? So
hey, go ahead.
Yeah, so for we carry very few patches now. In Mitaka we carried a ton of patches, but we upstream most of them. The majority though, if we have anything now, it's plugins. The only exceptions would be exactly like with Nova, for example, the scheduler filters. They might be pluggable now, but that's one of the areas where we couldn't make it plugins in Mitaka at least. So we kept them downstream, but making it pluggable would have removed any need for us to do any changes to actual code base, which is awesome. And I hope it's a pattern the community follows more, because plugins is great.
Yeah, it's a lot cleaner. I was wondering if having the extended maintenance in place, having branches open longer has resulted in more people upstreaming their changes. I don't know if anybody's got any visibility into changes landing in stable branch, like beyond when they used to expire. I know we used to have a lot of people that carried patches and ran their own CI, their own third-party CI, because the branch was EOL upstream, and they didn't even get to that version upgrade-wise until it was already EOL upstream. So I'd be curious to see. I have no visibility into it, but I would like to see if any more patches have landed towards things as they go into EM, or if it's just silent and dead.
So what I see today is that most of the extended releases that we have no maintainers. right? So I think the last one with maintainers is Stein, which actually it's quite new. All the others don't have any maintainer or contributions, I mean.
Well, hopefully that means that people don't need the batches there, but it may just mean they don't know that it's there either, or know that they can still contribute things back upstream to it, or they don't know how. Be interesting maybe to kind of put something like that out there, like super user article on extended maintenance and how you get something in there if you're carrying a custom patch that would benefit people.
Right, that will be great. So we have less than 10 minutes. I'd like to wrap up this with the war stories. Most of us are operators doing OpenStack for a long, long time. So what are your war stories with upgrades? Do you have any? I imagine so. Who wants to start? No one.
I could share a war story about upgrading at the edge. So we had, we found there was some specific things that required us to do upgrades at the edge, because, at the time, and that's been fixed, and part of the reason why we were doing it was we couldn't do upgrades while the system was still working. We couldn't do like a download and then a cutover. So the upgrade required like 3 hours of downtime to do it. It was really painful. So we had to do it with maintenance windows and a whole bunch of pain, and it required like 6 reboots to get it to all do it. So that was a war story.
Well, I can share that we did one upgrade that we didn't notice, or we only noticed that we upgrade after we did it. So that was the easiest upgrade ever. Once, this was a few releases ago, we upgrade to it because we are trying to test the new it version. We deploy a new virtual machine, as we always do. However, that virtual machine was connected to the main database. And of course, testing the upgrades, you do the sync, and then going back is quite difficult. So that is one of our war stories with upgrades. That was very fast and upgrade.
An upgrade so easy you didn't even know you did it.
Well, we noticed later.
I guess my most recent one was the when I went from Queens to Rocky. I recently started running Octavia for things, in particular for as part of heat stacks for OpenShift clusters. And I didn't realize, still learning things about Octavia, but custom, basically you have to go and build your image for your load balancers for your HA proxy instances, just using disk image builder, and then put it up there and add it in as a, add in the UUID to the configuration so it knows what to spawn. It's apparently much more finicky about what version of that VM or that image you're running. And when I finished the upgrade, it looked pretty good. My APIs were all working, and then people started screaming that their lights were down and things started ringing off the hook, even though all the instances were still running. And then I noticed that every single one of my load balancers was in a deleting state. and nothing was, I had no VMs whatsoever. So I just nuked all of the load balancer instances and could not respawn them because there was an incompatibility with the image that I had. So I very rapidly built the new image and stuck it in there and reran the Octavia config to change that UUID, and they all magically came back. But that was my most recent upgrade panic attack, I guess.
Yeah. I have one interesting one relating to Octavia. This was working with a customer where we got them up to train. And so this was like a ticking time bomb that we didn't know about. And so what Octavia does is every little bit of time, I think every like 30 days or so, it goes and renews the certificate that it uses, because it uses public-private certificate authentication to talk to the amphoras. The issue was the amphoras had a bug inside them where there was like it was a Python 3 related incompatibility. So it's like one of those things where you just have to like parse it as a string because it comes as bytes or something along those lines. And what would happen is, everything is working fine. When it came time to do the renewal, it would go make the request, ask the amphora to renew its certificate. It would crash in the middle of renewing its certificate, and then the amphora becomes unreachable anymore because the certificate that's stored is completely invalid. And now, the Octavia can't talk to that amphora instance anymore. And because it can't talk to it, but it still thinks it's alive, it's failing to recover from it to like turn it off manually. And then this is one of those things where like it happened with 1, then happened with 3, then like 5, and then like slowly they would just drop off every time you hit the 30-day mark, until we finally discovered the root cause was. And so it's definitely interesting because it's one of those things that only with time you end up starting to realize what the issue is. And it puts you in a locked position where you can't get out of it once one fails. So that's a fun one.
Yay. So I suggest that we go quickly through the comments and some questions in the chat. So Tim Bell and Eric Olof mentioned Python 2 and Python 3 related with the versions, OpenStack versions that people are running. I think we touched a little bit of that when we talk about live migrations. Then about plugins, I see Pierre that mentioned with Blazor that they are pluggable. And Anastasius mentioned Octavia, the certificates expiration. I don't really get it. Anastasio, if you have a few seconds if you want to give more information.
Yeah.
Okay. Okay, so we are ending this session. Thank you so much to everyone to participate on this. We have the other pod. Of course, we didn't touch everything that we have here. I think we can follow up all of this now during the following days. Thank you so much for your participation. I'd like to finish, especially for the active speakers and considering all your experience with upgrades. Do you have any advice for OpenStack operators that are starting with OpenStack? Few words.
It's really
embrace your inner upgrade.
Yeah, I always advise new people new to OpenStack to do a manual install. I know the install guides have maybe need a little bit of work, but figuring out what's wrong with them is part of the fun. So learn how each component actually works. So when it breaks, you know how to fix it, because it probably you'll probably break it at some point in time. But do embrace one of the deployment tools because they are fantastic. But I definitely recommend like learning the inner workings of it before you jump headlong into a production cluster.
Also, Belmiro, before we drop, I think Ashley was going to share a little bit of a summary and a couple of next steps for tomorrow, if that's okay.
Oh yeah, I definitely will pass to you. That was the goal.
Oh, awesome. Well, I'm passing it back to Ashley, but thank you all so much. It's an amazing session, especially Belmiro and everybody who engaged. And I think Ashley is going to summarize a couple of points.
Yeah, so thanks everybody. Thank you so much for joining. Thanks to all of our user stories presenters from Blizzard, OpenInfra Labs, and Verizon. We had amazing attendance today. We even had people from Sudan, Nepal, Costa Rica. We got over 100 responses for the what version of OpenStack are you running poll. Most of you are running train, so that's really interesting to learn. And we're always looking for this sort of information, so make sure that you take the user survey when you have a chance. I think we're dropping the link in right there. Yeah, so we're always looking for information. It's critical. Another place that you can share that information is in the large scale SIG. So if you're interested in joining that, make sure to visit that wiki. We'll also drop that in the chat right now. So that's a great place to connect with others and to continue these conversations. You know, obviously this ran long, and that's what we want. So we want to direct you to a place to continue these conversations. And if you're interested in connecting with each other, feel free to drop your contact info into the Etherpads that we've been using today, if you are comfortable with providing that and with people reaching out to you. So use that as a resource for sure. And then also we will drop an Etherpad into the master list of Etherpads, Etherpad Inception, so that you can see what's coming up for tomorrow. Jump in there, explore those a little bit. You know, just so you know what's coming up, drop your name in there so that we know to look for you if you're interested in hopping into any of those discussions. And shout out to Gregory and Hassan and Kala for joining the discussions today, and James. That's exactly what we want to see, and we love that. So yeah, so jump in those Etherpads. And there's also an Etherpad within that Etherpad to provide some feedback if you have any suggestions for how this event could be improved in the next couple of days. So yeah, and I'll turn it back to Mark to let you know what to look for on Tuesday and Wednesday.
Yeah, and so we have a list of additional topics coming up in the next couple of days. And, you know, we're talking about the tools, high availability networking and software stacks tomorrow. The link we're dropping in chat will take you to the schedule where the Etherpads are. So if you haven't learned by now, we love Etherpads, and we want to keep giving you the link so you can participate. And then, of course, Wednesday, bare metal is an exciting topic that I know a lot of people are interested in these days. Edge computing, of course, and then we'll be wrapping up the whole week on Wednesday. So with that, I just hope that you all had a good time with OpenDev and look forward to seeing everyone tomorrow. So thank you very much. Appreciate it. That's a wrap.
Bye. Thanks, Al.